Hey guys, and welcome to our third and final video for the Exponent series for Chapter 4 and 5 in the Math 10C Alberta curriculum. So today we're going to be looking at fractional exponents and how they work. Really everything about them. Okay, so in this case, we need some basic terminology. Let's start with the whole thing. This is called a power. Okay? The whole thing. Everything you see on the screen right now is a power. Okay? This is an exponent. This is a base. Well, this is also a fraction as well as an exponent. So it's a fractional exponent. Hence the name. This y is the denominator. This t is the numerator. Those two will be very important. Okay? So what that equation would actually look like expanded into a radical form would be either like this or like this. So either the y-th root of x to the power of t, or x to the power of t, and then you take the y-th root of that. Okay, so let's start with a pretty basic one here. 5 to the power of 4 over 5. What we're going to do is we're going to not touch the base right now. We're going to place the base. Okay. Next, we're going to look at the denominator and put that as the index. This is the index, by the way. Whatever number goes right over here is going to be the index. The denominator becomes the index of our radical, and the numerator becomes the exponent. So your initial base is going to be raised to the exponent of the numerator, and the denominator becomes the index of our radical. Alright, so that would be what it looks like. You can calculate that further if you wish. Okay, here's another thing. If you know fractions, you will know that some irrational fractions will, improper fractions can be reduced to whole numbers. In the case of 4 over 2, we know that we can change this 2 into a 1 and this 4 into a 2. How do we do that? We are dividing this by 2, and we're dividing this by 2 as well, giving us 2 over 1, which is equivalent to 2. So, does this work with fractional exponents? Clearly, the base would stay the same, and this fraction would reduce to the exponent of simply 2. Okay, so let's try it out. 2 squared is equivalent to 4. Okay. 2 to the power of 4, and take the square root of that. What will that be equivalent to? Well, 2 to the power of 4 is 16. And the square root of 16 is 4. So, yeah, they are the exact same thing. And knowing fractions will help you quite a bit. The one thing that you cannot do with fractional exponents, or I would heavily not recommend doing with fractional exponents, is changing them into mixed numbers at this level. Keep them as improper fractions or proper fractions. Okay. Here's the last example that we're going to see today. Y over x times 3 over 4. This is still going to distribute. Now, you could, so there are two ways to write this. You could either write this as my personal favorite way, like this. So we're going to raise each of the numbers within our base, which is a fraction in this case, to that exponent. Okay. Alternatively, and this way may be a little easier for some, we can also simply go ahead, take the, so that's the denominator is 4. We can still put y over x here. Wow, that is messy. Sorry. Y over x. And we can raise that to the power of 3. Either one can work. You could even raise it to the power of 3 like this, which is probably the best of all methods right there. Yeah, so there are quite a few things you could do with that. Of course, you can't go past this step, as clearly, yeah, we don't have any values. Okay. So let's try the challenge question as our wrap-up for exponents. So if you'd seen our previous exponent video, this question should be possible. I encourage you to stop the video right now and try it out for yourself. If not, I will show you how to do it in one moment here. Okay, so what we learned right over here actually is that we can look at fractional exponents and reduce them. Yeah, so 5 over 10 is quite clearly reducible. Reducible to 1 over 2. So 1/2, okay? Now, from here, we can choose one of these methods, and I'm going to use this one as that is my personal, in my opinion, it's the best method. So we're going to take the square root of this whole base, and we're going to raise that base to the exponent of 1. Except, when you raise anything to the exponent of 1, you can just ignore it. Yeah, since everything is always raised to the exponent of 1, naturally. So, we're just going to completely ignore that 1 there. So actually another way of writing this would just be the square root of 2. Anyway, sorry, not the square root of 2, the square root. Now, 16, as seen above, we have 16x squared over y negative 2. Okay, so furthermore, for distribution, what I personally prefer to do is go 16x squared over the square root of y to the power of negative 2. Okay, so from here, we can tell a few things. Firstly, this is a perfect square, or 16 is a perfect square, so we can write that down as a 4. Okay. What about x squared? X squared is also a perfect square, and we're just going to put the x then. Y negative 2. Y negative 2. Yeah. So, this is a 2. They can't cancel out completely yet. They can cancel out to a negative 1, but do not forget that negative 1. So we have y to the power of negative 1. How can we represent this? We're going to take the reciprocal of y, in this case 4x over 1 is going to be multiplied by y over 1, which, oh, fun fact, could also be represented like this. And there we have our answer. Thank you for watching our series. Good luck on the exams, and yeah.